In a parallelogram, two pairs of opposite sides are congruent. Next one, in a parallelogram, two pairs of opposite angles are what? In a parallelogram, the two pairs of opposite angles are what? They're congruent as well. In a parallelogram, the diagonals do something to each other. What do the diagonals do?
Bisect.
Bisect each other, cut each other exactly in half. And in a parallelogram, the consecutive interior angles right after each other are supplementary. So these four rules make up the kernel about today's knowledge. How do you apply them? Well, let's make sure we know what opposite and consecutive angles mean. Angle 1 forms a pair of opposite angles with which angle measure? Angle 1 is opposite to 4 or 2 or 3. Three. Thank you, William. Okay. Angle 4 forms consecutive angles with which angle numbers? Which ones are consecutive to 4? Is it 1, 2, 3? So there's two different choices here. Yep. Angle 1 is a consecutive pair, and angle 3 is a consecutive pair. Letter C, angle 4 forms a pair of opposite angles with which angle number? 2.
2.
Yeah, those are opposites. And then lastly, just kind of a higher level thinking, how many pairs of consecutive angles are there in this figure? Good, James, 4 is right. You've got 1 here, 2 here, 3 here, 4 here. Each of those makes a consecutive pair going around. There's a total of 4 of them. Any questions on these attributes or properties that are true about parallelograms? So now we're going to do the same thing, except we're going to apply it all. So let's begin with just making sure we know the definition. It's on the last page. Hopefully you're not flipping pages, look back at it. What is the definition of a parallelogram? Well, it's got to have 4 sides, so it's a quadrilateral. With a certain feature. The name helps us. It says parallelogram. So quadrilateral with 2 sets of parallel sides. All right, so what? It's a quadrilateral with 2 sets of parallel sides. How does that help us? Well, because if it is that, if it is a parallelogram, then it's got 2 sets of congruent opposite sides. And if it's a parallelogram, then it's got 2 sets of what? Anyone remember these? Two sets of congruent opposite
Sides.
We got that one in purple. What's the next one? Angles, good. And if p gram And diagonals. What do those diagonals do again?
Bisect.
Good. Bisect each other. Because they both get bisected and they both do a bisect. And let's do red. If parallelogram, then do you remember what the fourth one was? We've got opposite sides, opposite angles, diagonals. Consecutive interior angles are what? Good, James, supplementary. Supplementary. All right. So what we're going to be doing for about the next 20 minutes is I'm going to spend 5 minutes kind of teaching some stuff, and then you'll spend 20 minutes doing this. I'd like to show you how I would go about solving these problems, and then you guys will go and solve them yourselves. Step one, here's problem one. If I'm looking for AD, I want to identify what it is that's being asked. So I ask myself, is it a side length? Is it an angle measure? Or is it part of the diagonal? Because those are my choices, right? I've got a side length, I've got angle measures, and I've got a diagonal. So in this case, I'm looking for AD, which appears to be a side length. I know that if I look at side lengths, the side opposite will be congruent. So if this one's 8, then this one I'm looking for is also 8. And therefore AD is 8. DC is asking a very similar question. It's saying if I'm looking for this side length, I know that 15 is opposite, therefore this side length will also be 15. Now I'm going to look at an angle. Angle A. I mean, I wish I knew angle C because I know that opposite angles are congruent. But I don't have that. I have this one. That's because consecutive interior angles are supplementary. So if I want to find this one, I got to take 180 and subtract 68, and I get 112. And I know that because that's 112, this one's also 112. And if I'm looking for angle B over here, I know that either it's the supplement of this, or equal to that one, 68 degrees. How do you feel after one example? 5, I think these will be easy. I've already memorized these. This should be no sweat. 3, I might need to look at the notes a little bit, but it seems very straightforward. 1, I do not understand this. Good scores. I'd like to model one more problem. I'm going to model number 4. But in doing number 4, I'm actually going to draw it out bigger because I think it's hard to see that problem. And I would recommend that you guys do the same thing, at least for number 4. Well, I guess I'm doing 4 and number 6. Rather than look at what we're being asked to do, I'm going to see if we can just fill in what we know. So first of all, one of these angles is 21. Is any other angle on here also 21?
Angle D would be 21.
Okay. We have to be a little careful about how we name them, because remember, angle D could be this top one, this bottom one, or the whole thing. So which of those three are you referring to?
Well, based on what the diagram says, it looks like they would be the bottom one.
Okay. And you're thinking that this one matches to this one. And that's exactly right. I want to be clear as to why, though, because a lot of times people will say, well, it's going to be here. It's going to be split in half. Not true for parallelograms. Or it's going to be here because this is going to be like isosceles. Not true for parallelograms. But if I were to draw a more extreme parallelogram, it might be easier for you to see that this little angle is going to be the same as this little angle. And this 21 is up here, like this bigger angle will be the same as this bigger angle there. And as somebody just said in the chat, they are alternate interior angles. So if this is 21, so is this one. Okay, what about the 71? Which one would also be 71 degrees? Anyone? Bueller. Angle DCG, says Mari. Thank you. DCG is correct, because those are alternate interior angles. All right. And then can we do anything else, or is that all we get? Doesn't seem like enough. What about this thing?
Well, because of that, we could also find what angle GED is, and then from there we could find the other angles.
Okay, good. So we don't know what this is yet, but we do know that these two together add up to this. So 71 plus X equals 134. So X equals 63. And if we know this is 63, then this one up here is also 63 because they're alternate interior angles. All right, can we get anything else? What about this one up here? How could we find Y? Does that help? What's the relationship between this big pink angle, 134 degrees, and this yellow angle I've drawn, the big one? They're consecutive interior angles, aren't they? And if they're consecutive interior angles, then we know they're supplementary. So we can say that this 134 plus these two, 21 plus Y, should equal 180. So 155 plus y equals 180. So y equals 25, which means if this is 25, so is this. Okay, a little more complicated, but the same idea.